here's another problem about combinations and probability. Again, combinations is that thing that's a bit like permutations. This one is a little more interesting than the last example. In this one, we have 9 males and 5 females, and you need to select 3 pairs of dancers. Okay, so pairs of dancers. And so the question is, how many different ways could you select 3 males and 3 females? So again, if we just wanted to count how many different ways, combinations would be really useful, rather than writing out all the possibilities. So in this case, it's important that we are choosing males and females. So we're going to have to split this up into a couple of combinations. The first one is how many different ways could we choose the 3 males from the 9 that are available? So we say C9 comma 3, and then we got to do the math to evaluate that, and then we multiply that times another C. The other C that we've got is we've got to choose 3 females from the 5 that are available. So C5 comma 3. And if we multiply these two together, we'll get the total number of ways that we could choose 3 males and 3 females. One thing that you might want to do right here is you might want to go and try to do the calculation and see what you get, and then pick up the video again and see what I got. So right now, why don't you pause the video and try to do the calculation, and in a minute compare with what I got. So my calculations tell me that the result should be 840. So 840 different ways that you could select 3 males and 3 females. Now let's take a look at a question regarding probability. So far all we did is count how many different ways. Let's see how we could turn this into a probability question that we might be interested in knowing the answer to. So here's the question. Out of the 9 males and the 5 females that applied, if you chose 6 of them at random, what is the probability that you would end up with 3 males and 3 females just by random chance? Well, it turns out in order to calculate this probability, we'd like to know the total number of ways that that you could choose 6 people from the 14. And we would compare that to the number of ways that you could choose 3 males from the 9 and 3 females from the 5. So we've already done half the work. The only thing we're missing is what's the total number of ways that we could choose 6 people at random. And we can do that with a C. So let's go ahead and look at the probability. So we're looking at the probability of 3 males and 3 females. So first, on the bottom, we'll do the new thing, and that is figuring out how many ways could we select 6 people from the 14. And we do that by saying C14 comma 6. That gives us the total number of ways that we could select 6 people from the 14. And then on top we do the C 9 comma 3, and we multiply that times the C 5 comma 3, and then we'll get a fraction, and we could turn that into a decimal or a percent, and that would be our probability. Let's go ahead and take a look and see what that looks like. We already know on top that we have 840. Let's see what we get for the bottom number. Again, if you want, go ahead and calculate it, and then let's meet up. The other thing is you might want to try reducing this fraction and compare with what I get. So we end up with 840 on top and 3003 on the bottom, and that reduces down to 40 out of 143. Hopefully you were able to reduce that. And then of course we a lot of times will express probability as either a fraction or as a percent or a decimal. So let's look at those. And I ended up coming up with 0.27972 and then a lot more decimal places. In fact, it looks like this repeats. But we're just going to round it to, let's call it maybe 28%. And that gives us a rough idea of the probability. So kind of interesting. It's 33 and 33.3% would be 1/3, and so it's almost a 1/3 chance that if we just pick 6 people at random, that we'd get 3 females and 3 males. It's kind of interesting. Anyways, let's take a look at another problem. This was a warmer upper for one that might be just a little bit more interesting than this one. Oh, and one thing that I want to mention before we leave this problem is the idea that why did I choose C's? Why did I choose combinations? Why not permutations? That's something that I'd like you to think about. You are going to see some examples of permutations, and it'd be really useful for you to compare them. But as long as we're here, notice we are selecting 3 males and 3 females. That's similar to the word choose or draw or pick, and usually you'll use combinations when you see words like that. We're not concerned with the order. Notice that we say 3 males and 3 females. We don't know whether we picked 1 male and then 1 female and then 2 males and then 2 females. That nobody said anything about that. So it just, whatever order they came in, we ended up with 3 males and 3 females. That's why we use combinations. If we had said 3 males then 3 females, then order would be very important. Sorry about that warning. Anyways, again, just to repeat, if we were concerned about 3 males and then 3 females, then order would be important, and we would end up using P's instead of C's, permutations instead of combinations. So in this case, since we're just choosing and we don't care what order, we'll use combinations.